for question number 3? Read it, guys. Read question number 3. Tell me if you know what needs to be done for this, or do you need help with this one?
Sir, it is just like finding the HCF.
Yes, it is. Okay. So work on it quickly. Complete this one, all of you. You know how to find HCF, no? Enough number of times we have done that.
Sir, should we use Euclid's division lemma only, sir?
Yes. For practice, for now. Okay. So tell me once you're done.
Completed, sir.
Okay, that's good. Ritisha's completed. Let me know once you're done.
Completed, sir.
Okay. Nitya has also completed.
Completed, sir.
Pragati, is that you?
Yes, sir.
Completed, sir.
Okay. Vidula also completed. Good. I couldn't hear the last person. Who's that?
Midula, sir.
Vidula, yeah. Vidula, I got you. Yeah, completed. Good. Okay, so I'm not going to solve this third question. I think everybody should know how to solve this. Let's move on to the fourth one, guys. Okay. Anybody needs help with third one? Tell me. I didn't hear anything from Adi, Charan, Deep, Manoj. Are you people done?
We're going to finish, sir. Yes, sir.
Okay.
Yes, sir. Yes. Sir, completed.
Okay. Tanushri, Kavya.
Yes, sir.
Okay. Fine. So
Sir,
Mhm.
sir, if the fourth question comes in the exam, like in the public exam, they'll also give that hint, sir.
No, they won't be. Because these are like new type of question, no? You would never have done questions like this in previous years, right? It's a totally different kind of question. That's why they have given you some hint over here, but don't expect a hint in exam, of course. Okay.
Okay, sir.
Have to learn to do this on your own. Maybe guys, when you're done with the third one, I'm still waiting for some people who are not completed. Okay, that's enough of time for solving question 3. Let's move on to question 4 now, guys. Okay. So what are they saying in question 4, everyone? They're saying use Euclid's division lemma to show that square of any positive integer. So if it is Euclid's division lemma, you remember A is equal to BQ plus R. So we need to decide whenever you have this kind of a question where you have to prove that or show that some number is of the form 3m and 3m plus 1 or anything like this kind of question. I mean question 4, question 5 or question 2. This kind of question, you will have to decide on what my A is going to be and what my B is going to be. So A is the easy part. Whatever they tell you in the question, square of any positive integer means any positive integer will become your A. Don't put the square of that. We will do the squaring later. Okay, let A be any positive integer. So this is your A. Now, what should be my B? That will you will look at this form. What you want to show it as?
B will be B, sir.
Yes, looking at this, it's very simple that B we can take it up as 3. Okay, so
Sir, then the M.
see, M could be any integer. We don't care about that. Okay, we'll see. So, like I said, no, for Euclid's division lemma, A and B are the two numbers. These are important numbers, right? Once you have decided what is my A and B are, then we will just apply the division lemma, and then all the things will fit into the place like this, and you will automatically get that M over there. Okay, I'll show you how that comes. Don't worry about that. Okay, so decision part, you have to start with A and B. So A is going to be any positive integer. We will do the squaring later, remember, okay? We'll take A, we'll write that in the form of division lemma, and then we will do the squaring later. And then B, we are going to divide the number by 3. So B is our 3 over here. So let's start with that. We'll
Sir,
say,
I completed, sir.
okay, that's good. Let A be any positive integer. And dividing by 3. Let's divide the number by 3 means B is equal to 3. So by Euclid's division lemma, what we can say? Tell me, what should I write, guys? A is equal to what?
3 into
Some quotient Q plus R. That's all. Okay, don't worry. Of course, we don't know what is Q and R. No, we don't know what is A. So how can we divide? How can we find the quotient? So we have to keep it as a variable only. No. So Q will be a variable. R will also be a variable. Now, what is the value of R? What all possible values of R are there? R can be anything greater than 0, or It should be less than what? What is our divisor here? 3. So it should be less than 3. So the moment you write this, now you have got some possible set of values for R. What are those values? Who can tell me? What are the
0, 1, 2, sir.
0, 1, and 2. These are the 3 possible values of R. So we have to take it one by one. Okay, all these 3 possible values, we have to take it one by one. Let's say case 1, where R is equal to 0. Okay. So if R is equal to 0, how we will be able to write A as? A will be 3Q plus 0. That means A is equal to 3Q. Everyone understands this one? This is very easy, right? In this case, we have taken R is equal to 0. So this R becomes 0 here. So A will become equal to 3Q. All right. Then remember still, A is just any positive number. We have not done the squaring. We have to prove that square of this number is of some form. Whatever form it is, 3m and 3m plus 1. So we have to do the squaring first. So square both sides. So squaring, what will
A
happen?
square equal to 9Q square.
9Q square. Now remember, this 9Q square, now look at the question also. What form they are asking you? It should be of the form 3m or 3m plus 1. So which of the 2 forms do you think your answer over here, this can be written as? Can it be written as 3 times of some integer or 3
Sir, can
times
you
of?
repeat the sentence, sir? I didn't understand, sir.
Okay, I'll repeat. See, I have got A is any positive number and A square is the square of any positive number. This is what A square, I need to prove that it is of the form 3m or 3m plus 1, correct?
Yes, sir.
This A square, I need to prove that it is of the form 3m or 3m plus 1. See, m, we don't care what is the value of m. M is some integer, any integer, we don't care. So in the place of m, it could be anything. So I'm telling you that this 9Q square can be very easily written as 3 times of some number m. How can you do that? Just split the 3 from 9. Can you not write it as 3 times of Q square?
Yes, sir.
Everyone understood how this came? 3 times of some number 3Q square. That's what becomes 9Q square, right? So this whole thing, this is what will become our m. Q is some integer we know. So Q square will also be integer and 3Q square will also be integer. So we don't care what is the value of m. So we will just write it as it is 3m, where m is some integer. Correct? A square can be written in 3m form. Now, this was the first case only. I have taken only R is equal to 0, but we know that A can be represented with
What
R.
will happen to one more 3, sir? That one more 3 is there, no, sir. You said A square can be written in form of 3m. Then
Yeah.
what can we do? What that?
See,
Oh, that 3 square is there.
yeah, this 3 is over here. This is the 3 over here.
Understood, sir.
And this whole thing becomes your m. Okay? Everyone is okay? Sorry about that. Just give me 1 minute. Yes, guys, let's continue. So everyone understood, right? From this 9Q square, I have split it.
The recordings.
Yes, I started recording. Yes. Yeah. So 9Q square, I have split it up as 3 times of 3Q square, where you can see that 3Q square, I can consider it as some integer m. We don't care the value of m, no? So whether it's 3Q square or whatever it is some integer only, no? So we'll just call it as m. And then that's what A square has taken this form now, 3m form. Square of any integer can be written as 3 times of some integer m. Okay. Now, this was just the first case where R was equal to 0. Now let's consider the other cases. Case 2. What we have to consider this time? R is equal to 1. Everyone remembers how many possible values of R is there? What are the possible values? R can be either 0, 1 or 2, right? because it has to be greater than 0 and it has to be less than 3. Greater than equal to, I mean. So that's why we are considering 0. But this is just less than 3, so we can't write 3 over here. Remember that. Don't write 3 over here, okay? 3 is not possible. Only 0, 1, and 2. 3 possibilities. And each one of them will become case for us. First one we have done. Let's go to the second one with r is equal to 1. So if r is equal to 1, what will be my a value? Tell me. I expect you people to tell me now. What should be my a written as?
3q plus 1.
Plus 1.
3q plus 1. Very good. R has become 1 now. Okay. Now what is the next step we have to do? This is some positive
Square.
integer. We have to square it again. Of course. Very good. So a square will become 3q plus 1 ka whole square. Everyone knows the identity. Expand it and tell me 3q plus 1 whole square, what it will become. Tell me, what should I write? Tell me, guys.
Sir, a plus b whole square identity, sir.
Yes, a plus b whole square. So it will be a square plus b square plus 2ab. So tell me, what is it? A square?
9q square
9 square plus
Plus
1.
plus 1
Yes.
plus 6q.
Yes. So I will write it like this. A square plus 2a into b plus b square. This is how I will write. So my a is 3q and b is 1. So this is how I will write it. Everyone is okay with this?
Yes, sir.
So 3q square becomes 9q square plus 6q plus 1. Okay. Now, again, look at it. A square has taken this form now. How can I represent it in the form of 3 multiplied by some integer m or 3 multiplied by some integer m plus 1? Which one do you think it will be possible this time?
Sir, 3 multiplied by m plus 1, sir.
Yes, this time we have to take consider of this 1 because there's a plus 1 over here. No, we will not be able to take the 3 common out of this 1 over here. Okay, so what we do from these two, you see there is a 9 here, there is a 6 here. So I can take the 3 common from there. Take the 3 common, don't take the q outside.
Sir.
Q also no need. We don't need of that q. You see 3 multiplied by some integer, no? So I just
Yes.
need by 3 outside. So don't take q outside, even though it's possible over here. Okay. Everyone understands why I have not taken q outside? Because we don't care about that. We are not solving any problem here. We are trying to represent it in this form. Okay. We are not trying to simplify or solve this problem. We are just trying to represent it in the form of this or this, whichever is possible. 3m plus 1 is possible this time. So I will just take the 3 common. So what's remaining inside? 3q square plus 2q.
Plus 2q.
And plus 1. Now you see, does it not look like this form? 3 multiplied by some integer 1, m. But m is this whole thing. This whole thing will become m for us. Because that is also an integer only, no? Q will be some value. When you put the value of q, the whole thing will become some integer. We don't care what integer it. So we'll just call it as m. Is it clear? So 3m plus 1, where m is equal to 3q square plus 2q, which is some integer. See, you can write it as belongs to I. If you write like this, means it is some integer, okay? In this case also, you could have written here where m is equal to 3q square, which is an integer. Okay, so now we have proved that square of some integer a can be written in the form of 3m plus 1. So both these cases were either the first one, that is 3m or 3m plus 1. Now a square can be represented in one more way. What is that? Using r is equal to 2. So we need to go to the third case now. Okay, so go to the third case where r becomes 3 this time. Sorry, 2 this time. Case 3 where r is equal to 2. Tell me, what should I write? What will be my a? guys?
3q plus 2, sir.
Yes, it will be 3q plus 2. What should I do next? Square both sides, right? I need the square of a, no? A square is
Yes,
equal
sir.
to 3q plus 2 ka whole square. And then expand it. So this will become what? 9 q square plus 12q plus
Plus 4.
4. Okay, now there is a problem. How do I
Sir,
represent?
we can split the middle term, sir, here.
See, again, remember, we are not trying to solve this. Even though this is a quadratic polynomial, we are not
Sir,
trying to factorize or solve
we
it.
can take 3 as commons. It will be 3 will come out and it will be 3q square plus 4q, sir. Then plus, after bracket, plus 4 will be there, sir.
Yeah, but did they say that I can write the number as 3m or 3m plus 1 or 3m plus 4?
No, sir.
Is there a form like 3m plus 4? So what should I do with this 4 here? This guy is hurting me. What can I do?
Sir, plus 3 and plus 1, sir.
Yes, I can see even inside this 4, can you see a 3 is hidden? Can I not write it as 3 plus 1?
Yes, sir.
So I will be able to separate the plus 1, and from the rest of the things, I will take the 3 common. So my 3m will come there, correct? It will become 3m plus 1 form.
Yes, sir.
Okay, so let's do that. So let me write it one more step to make it easy. 9q square plus 12q. Instead of 4, what I'm going to write now? 3 plus 1. Okay, so that from this whole thing, I will take the 3 common, and it will become 3 times of some number plus 1. Well, plus 1 will be left alone as it is, and it will take up this form. Okay, so let's do that. Take the 3 common, so it will become 3q square plus 4q plus 1. That will be inside the bracket, and then other than that, plus 1 is remaining. Now what we can do, everybody understands that this whole thing I can consider it as my some integer m, because this will be some integer only ultimately. So this I can write it as 3m plus 1, where m is 3q square plus 4q plus 1, which is some integer. Okay. So now we saw that any number a can be represented only in 3 ways, either as 3q plus 0 first form, or 3q plus 1, or 3q plus 2. And we tried doing the square of all of
If
them.
then we can do any number in the make any number in the form of 3m plus 1 or 3m, no, sir.
Yes, any number we can write. Any number, when you do the square of it, that can be written in this form, 3m or 3m plus 1. You can try that actually. Take the square of any number. Either it will be written in the form of 3 times multiplied by some number plus 1. So let's take an example of, let's say, simple number like 5 itself, 5 square. It is 25. So this 25 can be written as 3 times of some number plus 1. So if you want to do that, just do the simple division. 25 divided by 3, what will happen?
Sure.
3 8s are
6.
24 plus 1.
Yes, sir.
You can take examples, some other examples also, bigger numbers also. And divided by 3, you will get some q. A remainder will always be 1, or it will be 0. 1 or 0, any one of them. 3m plus 1 or 3m. Only 2 ways to represent any square of any number, positive number. Okay. Everyone is okay with this, guys? Tell me, confirm.
Yes, sir.
Okay, good. Now,
Yes, sir.
let's move on to the Next one. Fifth question. Let's complete this exercise today. We have been sitting with this for too long. I don't want to. Yeah. Fifth question. What do you think we can do here? Same thing, using Euclid's division lemma. That means we have to decide what is our A and B. Who will tell me what should be my A here? What is my A?
Any positive numbers.
Any positive integer, not number. Number means so many things. Integer,
Yes,
be
sir.
careful. Yeah. And later
Any
what we will have,
positive integer
and
till
remember that
9.
remember that once we have written A in the form of division lemma, for each case we will have to do the cubing this time, because they're saying that cube of each number. Okay, like in the previous case we were doing squaring, this time we'll have to do cube of that number.
So
Okay.
this time the remainder is going till 8, sir. So we should prove all 8 cases, sir.
No, let's see what happens. Let's see what happens. So there is a 9m plus 1, 9m plus 8. What should I do? What should be my B value here?
9, sir.
Everyone agrees? Should it be 9?
Yes, sir.
Okay. Let's see what happens if I take 9. Question 5. So let A be any positive integer and B is equal to 9, let's say, like you people are telling me to do. So if I do that, if I take B is equal to 9, how many ways to represent A? A will be 9 times of Q plus R. And what all values R can take? It can be greater than 0 and less than 9. So what are the possible values of R now?
1, 2, 3, 4, 5, 6, 7,
Not
8.
1, don't forget 0, it's important. 0, 1, 2, yes, 3, 4, 5, 6, 7, and 8. So there are totally 9 cases which you need to consider. So it will be morning by the time we start complete this one, okay? But remember, every time you write this, you have to do a cubing, right? We have to do a cubing. So once you do the cubing, if you do a cube of 3, what happens? 3 cube anyway will become 27. Inside that 9 will be hidden somewhere, no?
Yes, sir.
Inside,
9 into 3.
yes. Inside the 27, 9 is hidden. So don't take B itself as 9, but take B is equal to 3. Because once you write it as 3Q plus R, where R will be between 0 to 3. Now this time R will be very simple. R could either be 0, 1 or 2. Only 3 possibilities. But anyway, we will be doing the cubing of these numbers for each of these
Sir,
cases.
how can we take B as 3, sir? Because in question they have given 9Q plus 1 like that, no, sir.
We have to represent it in this form. So even though if we take B is equal to 3, because of the cubing, we will be able to write it as 9m, 9m, 9m.
Then before questions also we can do like that, no, sir. We can take any, if the before questions also, if the number was big, then we can do like this, no, sir.
Yes, we could do if the number was bigger, and by taking a smaller number, if you are still able to represent it in this form, then you should be able to take that smaller number also. Okay.
Yes, sir.
Okay, but the thing is, previous cases we had 6 and 3, so they were already small numbers, and even in this case, what number can you take? You will not be able to, because there is nothing like squaring or cubing, nothing is happening over here. So you can't make that into, if you take 2 or 3, you will not be able to convert that into 6Q. Okay, that's why I couldn't take any smaller number for the second question also. And fourth question, it's already 3. So how small can you go below that? You don't need to go anything. Only in fifth question, when the number is little bigger, 9. So I could have taken B is equal to 9. There is nothing wrong. You will be able to prove the same thing using 9 also. But only thing is you'll have to use 9 different cases. That is unnecessary waste of time, no? So since we already know that we are going to do cubing, and cube of 3 will always give me 27 there. So 9 will be hidden there. So I can take out that 9 common. Like every time we were taking 3 common in the previous case, we will not take 3 common. We will take 9 common this time. Okay. So process is going to be very similar. Remember, these are the three possible ways in which the number can be represented. Either 9m, 9m plus 1, or 9m plus 8. So keep an eye for that, those three cases. Okay, when r is equal to 0, what should I write, guys? A is equal to
3q plus 0.
3q plus 0. So A will be 3q. Now what should I do? This is just A is my some integer, positive integer. I have to do cube of that integer. No, then only I will be able to prove whether that is of the form this or not. So we'll do cubing. So A cube is equal to 3q whole cube. How much is that? 27q cube. Now, can you take 9 common from this or not? Can you separate 9 from this? Yes, you can. You can take 9 times of 3q cube. And I can consider this whole thing to be my integer n, so that it will take the form of 9n. Everyone is okay with that? Everyone understands what's happening here?
Yes, sir.
So m is 3q cube, which is some integer. So first case, it's done. It was of the form 9n. Any cube of any integer a can be written in the form of 9n when I take r is equal to 0. Now let's take the second case, r is equal to 1. Tell me, what should I write, guys? Be very, very quick. Tell me.
3q plus
1.
Okay. Next, what should I do? Cube.
Cube of both, sir.
Yes, cubing both sides. So it will be 3q plus 1 whole cube. So now this is again an identity expanded. A plus b whole cube. What will it become?
A cube plus 2a square b plus 2ab square plus b cube.
Yes, when you have a plus b whole cube, you should remember this identity. Now, you're in 10th standard, everyone should remember this identity. And it can take two different forms. Do you people remember? It can take,
Yes, sir. A cube plus B cube plus 2AB and A into A plus B, sir. Or A cube plus B cube, then 3A plus 2A square B plus 2AB square.
yeah, so they are not different. Basically, you just distributive property, you multiply these one by one and you expand it. That's what you're doing over here, okay? Or not two actually, there is a 3 over here, okay? So 3A square B and 3AB square. All right, so let's do this. So which form do you think it's better to take? I think it will be this one. It's better. I will be able to take the 9 common easily from this one if I do this.
If we take up one also, however, we should multiply, no, sir, with that.
Yeah. However, you'll have to expand it anyway. So why to waste one more step? Directly go to this step only. Okay. Yes, that's true. So it will be a cube, that is 3q ka whole cube, plus b cube, which is 1 cube, plus 3 times of a square. What is my a? 3q ka square, and into b, which is nothing but 1, a square b, and then 3ab square, which is 3q into 1 ka square. I have just expanded the identity a plus b whole cube. Everyone is okay with this so far? Tell me, quickly confirm yes or no.
Yes, sir.
Okay, now just simplify this. 3q whole cube will become 27q cube plus 1 plus 3 3s are 9q square. No, not 9. 3 square will become, this is 3q whole square, remember, okay? So
27.
Yeah, so this is itself 9q square, and 9 into 3 will become 27q square. Again, this one, 3 3s are 9q. Okay. Now, which form do you think it will be? Can I write it as 9m? Is it possible? Is 9 there in all the terms?
It's 3AB or 2AB, sir. The 3A square B or 2A square B, sir.
No, it will be 3, okay? In a cubing, it will be 3ab square. 3a square b, 3ab square. Okay, because of the plus 1 you see here, we will not be able to take 9 common this time. So I can't represent it as 9m. What should I do? 9m plus 1 looks like a better option over here because everywhere else 9 is there, no? I can take 9 common from there and plus 1 will be left. Can everyone understand why am I writing that as 9m plus 1?
Yes, sir.
Okay. So let me rearrange 27q cube, 27q square plus 9q plus 1. And then from these three terms, I'm going to take 9 common. 3q cube. Tell me, someone help.
Plus q square.
Yes. So I can write this 9m plus 1, where m can be any integer which is equal to 3q cube plus 3q square plus q, and this is some integer. Okay, so this has taken the form of 9m plus 1. It's 9, not q. Now, the last case. What should I write? R is equal to 2 this time, correct? So what will be my number? A can be written as 3q plus 2. Do the cubing again. A cube, 3q plus 2 whole cube. Expand the cube again. 3q ka whole cube plus b cube plus 3a square b and 3a b square. So my a is 3q, b is 2, this is 3q, it's 2. So it's again, this one is same, 27q, this is 8. What about this one, guys? Tell me, what is it?
54 q square.
54 q square.
54q square. Very good. What about this one?
36 q.
36q. What should I do now? So the constant term is plus 8 over here. Remember, in this case, if it was greater than 9, suppose it was 10, then I could have taken the 9 plus 1 over here, and I would have been able to write it as 9m plus 1. But that's not possible here. So what can I do? I have to leave it as plus 8 itself. Take the other three terms, write them together, and leave the plus 8 alone. 27q cube, 54q square, 36q plus 8. So from these three terms, I can take the 9 common. So what should I write, guys? Tell me.
3q cube, sir.
3q
Plus 6q plus 4q.
plus 8. Okay. So this is what we can write it as 9m plus 8, where m and it is some integer. Okay. So what did we understand? That any cube of any integer can be written only in 3 different ways, either 9m or 9m plus 1 or 9m plus 8. Okay. So with this, we have completed NCERT exercise 1.1. Anybody has any doubts in this, guys? It's easy, right? Even though it seems a little complicated, but actually it's easy, right?
Yes, sir.
Yes, sir. Doing method only, it's too long.
Yeah, method could be a little lengthy, but still the process is very same. Same thing you keep doing again and again. Only thing you had to use a plus b whole square identity over there, and here you had to use a plus b whole cube identity, and then you had to take few things common. That's all.
Yes, sir.
Okay. So practice these questions. If you don't practice, you will forget what to do. Okay. These are like this is very less like maths. It's more like theory. You have to practice this and remember what needs to be done. Not much to put your brain into this. Okay, you have to just remember how to do these steps. All right, so that's it for the maths class today. Let's take a break and then come back for 10 after 10 minutes.